nervous system or human system. And the same thing I'm comparing with the artificial neural network. You see that in the artificial neural network, so input section is there. So this input will be forwarding to the hidden layer process, and hidden layer process will be process it, and then finally it will be what produce the output. So this is the artificial neural network, and this is the human nervous system. So comparison between these. And the structure of the typical neuron. You see that here is the number of neurons are there. You see that in this. So 1, 2, 3, and so on.
Hello, na? Hello, sir. Hello, sir. You are muted. Unmute change, sir. Viswanadha, sir. May the mute lo undi. Mute lo. Yes. Now it's okay.
Okay. When it was unmute? Only here.
Sai. నేను ఇప్పుడే చూస్తాను సార్. ఒక్క నిమిషం ఏంటది రాబోడి సార్. మీకు ఎప్పటి నుంచి వినిపలేదు సార్? ఏమింటారని నాకు అర్థం కాదు. రమేష్ సార్, మీరు ఎప్పటి నుంచి విన్నారు? మాట వినిపలేదు ఇంతకుముందు.
Sir, it is only for 1 minute, sir.
Only for 1 minute, sir. Yes, sir.
It is only for 1 minute.
Yeah. So thank you. So you see that this is the nervous system, human nervous system structure, and this is our model artificial neural network. In the nervous system is inputs and hidden process and output. You see that the same thing we are re-representing in the form of artificial neural network. Here is input, and this is the hidden nodes or hidden layers, and this is the output. You see, this is what. So this structure is the typical neuron. So here is hundreds of neurons are maybe there. So that one neuron we are trying to understanding. Then this neuron will be comparing with our artificial system. That is what I'll be going to share with you. So let us see, here is the neural network concept introduced by MC Pitt in the year of 1943. This is long back it was introduced. Now it is playing the key role, no doubt. And how you see that many of the principles can still be seen in neural networks of today. And you see that how we are comparing with the biological nervous system and artificial neural network system. You see that. Though you see that neuron is equivalent to the processor element we are considering. Just they have been mapped like this. So this is what I have been collected from the literature. And dendroid, you see that addition function, and cell body is a transfer function. Axons are artificial neuron outputs. Synapses are weights. So like this, they have been compared with each component. And finally, they have been designed one kind of a structure for the understanding of the user. So let us see this. So let us see here the weights. So weights parameters. Weights. A weight represents the strength of the connection between units. I think it looks like a graph structure only, but we need to consider the definition of the artificial neural network. What is the definition of the artificial neural network means? It is a combination of 3 different layers: input layer, hidden layer, output layer. But the structure looks like that, but we want to re-represent, and we need to consider certain parameters, certain features. The weights. Weight represents the strength of the connection between units. So let us see here, this is one unit and this is another unit. Let us take it, this is one unit and this is another unit. Between this, there is an edge. The edge is called a connection. A connection is called, it is a, what is saying, A weight represents the strength of the connection between units. So this is edge. This W is called weightage of this input data. 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 So what is the importance of this weightage of input data? Let us see. I'll take one example. An example how it is playing the weightage a role. So kitchen example, let us please consider. Suppose if I want to prepare a chicken curry is my output. For that, what I required, certain gradients are required. What gradients are required? Oil, salt, chicken, etc. Let us assume oil as a one input, that is what A1, and chicken is the second input, A2, and salt is A3, and so on, with respect to the your quality, your taste. Okay, so like this. But you see that at the same time, how much quantity I have to use for making my project. My project is called a chicken curry. So how much quantity of the oil, how much quantity of the salt, how much quantity of the chicken. Like you see that is what this edge is representing the strength of the connection between the unit to unit. So like you see that weight is having the highest importance. Suppose if I should not follow the balancing weight, then what is the taste of my chicken curry? I should not eat. Suppose if I take a salt, maybe 1 kilo for 2 kilo chicken curry, then what is the taste of that? So I should maintain the balancing among the weights of each gradient also. So that in that case, the weight is playing the key role. So this is what I'll be going to discuss in today and tomorrow. Please, all of you be carefully follow my session. Then easy to understand, easy to implement, easy to enhance it for your research. Once again, I'm repeating, a weight represents the strength of the connection between units. So unit to unit, there is edge. This is representing the strength of the unit. If the weight from node 1 to node 2 has a greater magnitude, it means the neuron 1 has a greater influence over neuron 2. Suppose you see that W1 is 99, W2 is 1, Wn is 1. Then which is having highest weightage? So this is more influencing input. This is what? More influencing input also. Even let us take in our college, the principal is also maybe receiving data from different faculty member. Sometimes some faculty may be influencing the principal also. Because of that is what strength of the faculty. It means that neuron 1 has a greater influence over neuron 2. A weight brings down the importance of the input value. The weight brings down the importance of the value. If the weight is 90%, A1 is having the highest importance. If the weight is 1, weightage is having the lowest importance. So this is what you see that. A weight brings down the importance of the input value. So now, weight is the parameter within a neural network that transforms the input data within the network's hidden layers. You see that. So this is a neural network is a series of nodes and neurons. Within each node is a set of inputs, weight and bias value. Often the weights of neural network are contained within the hidden layers of the network. So let us look into this overall structure. These are the input values and these are the edges are representing by weightages. And again, one more value, that is what? Bias value. So bias value. So I think you are very much familiar about the general formula. That is what we might be seeing in mathematics, y is equal to mx plus c. This overall structure looks like y is equal to mx plus c only. How I can say this is mx plus c means B bias is nothing but a C, let us assume. And mx plus c means M is a what about a C, that weightage. There we might be considering mass. But in this example, what I am doing here is y is equal to W1 multiply A1 plus W2 multiply A2 plus and so on. Wn multiply An plus bias value, you see that, plus B. So this is the overall function, additive function, that is called additive function. Additive function is, so looks like a y is equal to mx plus c only. So this is what you see that. Then again you need to apply the activation function, certain threshold value. If it is crossing certain threshold value, so that is not good. If it is not crossing, it is a good. Like that you see that you need to apply the threshold function. That is what? Activate function. Activate function. So this is playing the key role. So now I think you know that what is the importance of the weight. Weight is the influencing parameter. If the more weight is there, this input is influencing the overall system. Okay, this is what we might be observed in our places also. Input layer. The training observations are fed through these neurons. Input layers. The hidden layers, these are the intermediate layers between input and output, which help the neural network learn the complicated relationships involved in data. You see that? So this is what input data and this is what output data. Between this, there are n number of hidden layers are there. So hidden layer 1, hidden layer 2 and so on, kth hidden layers. So this is what intermediate layers. I can say hidden layers are nothing but intermediate layers for connection between the input and output. Output layer. The final output is extracted from previous 2 layers. Okay. For example, in case of classification problem with 5 classes, the output later will have the 5 neurons. You see that. So this is what the process of the neural network concept. Okay. Let us say this is the same thing which I have been explained to you. I re-represented only. This is what re-represented. Input artificial neuron. Okay. So this is what. Now we want to consider, here is a perceptron concept. So each neuron, how it processes, how it works, that is what I am going to discuss. Each neuron process. First, once I understood individual neuron, then I can go for the sequence of neurons for the input to output. So that is what the perceptron. A computational model of a single neuron. Computational model of a single neuron. A perceptron consists of one or more inputs, a processor, and a single output. Let us see. So this is what you see that this is overall structure is called a perceptron. So what we discuss, if this is a neuron. A neuron is having the different components. What are the components? Input, processing, output. You see, the processor is receiving from from different sources like input 0, input 1, and it will be processing and producing an output. So this is one neuron. This is one neuron. So this the same thing I am re-representing in our system. In our system means, let us see here is what is meant by input. Here is this is that inputs I am taking x1, x2, x3 and so on, xn. That is what your wish. N number of output inputs and also weightage of each input. This connection is making the connection. What about this connection indicates? Weightage of the input W1, W2, W3. So these are the synapses and these are the inputs. And what is the neuron? You see that neuron is a additive function. Additive function means summation of this all. You see that inputs of and weightages. So this is what this function. You see that y is equal to W1 x1 plus W2 x2 plus W3 x3. That is what additive function. And this is what you see that y output value with a threshold value or maybe activate function. So here I can use the activate function. If more than certain threshold value, then so and so output. If less than certain threshold value, so and so output value. So here I have to apply the activation function. That is as per your requirement that you decide. So this whole structure is called a perceptron. A perceptron follows the feed forward. So this is only feed forward. It receives the input data and process it and produce the result. So it doesn't have any back propagation. It doesn't have any looping. It doesn't applicable. What about that looping? Meaning inputs are sent into the neuron or processed and result in an output. You see that it is receiving the input data and processing and producing an output. Same process here. Network reads from left to right. Generally, every neuron reads from left to right. Even our human brain also, it reads from the left to right, from input to output. So input comes in and output goes out. So this is the process of the perceptron. Okay. Once we understand the perceptron, then easy to understand the concept of other one. So let us see here. I have given one example, perceptron algorithm. What is the perceptron algorithm? So this is very basic information for understanding of the artificial neural network. For every input, multiply that input by its weight. You see that for every input, multiply that input by its weight. You see that this is what? This is what you see that sum function, additive function. Sum of all the weighted inputs. This is what weightage multiply input value. Compute the output of the perceptron. Compute output of the perceptron. Based on that, sum passed through an activation function. The sign of the sum. Let us see here is. So this is what receiving the input and giving the weightage for each input and additive function and finally producing the value with based on the threshold. That is what I will be going to share with you. Let us consider two arrays, how to write a program in C language or maybe in Java or any other language for the perceptron. Let us consider two arrays of numbers, the inputs and the weights. You see that. How to take input and weights. Both are same size only. Suppose n inputs are there, n weights are required. So that is what you see that inputs and weights I am taking an array. Next, for every input, implies a loop that multiplies each input by its corresponding weight. Since we need the sum, we can add up the results in the way at very loop. You see that in every loop. Let us see here is how many inputs are there. There may be n number of inputs are there. So when it is having the n number of inputs, what I want to do, I want to do the summation of all the input and weightages. So for that purpose, what I'm doing here, I'm applying the looping statement with respect to the number of inputs only. Number of inputs. Suppose one input is there not required. If there are more than two are equal to inputs are there, then I must use this function within the looping statement only. So when it is having the more than or equal to two input values, okay. Then once we have the sum, we can compute the output. Now let us see here is once we got the summation value. That summation value I have to be considered with the help of the activation function. Summation is greater than 0, then return 1. If summation is greater than 0 false, then return -1. So this function is as per your requirement. As per your requirement, you have to be consider this. Okay, like this, I have to be write a program for the perceptron algorithm. So this is the way of writing for the artificial neuron. First, once if you know the writing an algorithm for the single neuron, the process is the same for hundreds of neurons also, or sequence of neurons also. The same thing I explained here. You see that the perceptron with the two inputs, x1 and x2. x1 value 12 I am taking initially, x2 value I am taking 4, and the weight inputs, you see that. But how to take the weight inputs? This is very important. You see, when I used to try to prepare the chicken curry, how do I decide the quantity of the each gradient? Randomly. Today I do it randomly. If the taste is good, then I follow the same weightage. If I should not get any good taste, then I should change the weightage of the quantity of the each gradient. That is the process only we are applying even in the home also. The similar process we want to apply in the artificial neural network. You see, let us here, weight inputs. When creating a perceptron, we will typically begin by assigning random weights. So generally you see that even when I want to prepare the chicken curry, what I do, random weights I have to take it. Not accurate, not with the weighing machine. So random weights. If it is a good, I follow the same weight. If it is not good, I'll change the weightage formula next day. Okay. Often number between -1 and 1, such as weightage initially random value I'm taking 0.5 and weightage 1 is -1 I'm taking. We take each input and multiply it by weight. You see that when I multiply with this x1 value and x2 value, finally I'm getting what is the value. So this x1 multiplied weight 0, 6, x2 multiplied weight 1, -4. Then some inputs. What about you see that? These are the inputs now for the neuron. The weighted inputs are then summed. 6, whatever the values are I received with this computation statement, 6 - 4. So then finally 2. The generate output function. The activation function is what? Tell the perceptron whether to fire or not. So now the neuron is fire or not. How it is deciding on the basis of the activation function. What is the activation function? My activation function is sign. If the sign operation. If it is a negative value, then I'll be producing -1. If it is a positive value, I'll be considering as a positive value only. So this is what my sign activation function. Like this, you can consider your own way. So suppose if you are doing certain process, in that process, you can define your own activation function as per your requirement, as per your target only. So this is what the whole process of the perceptron. This is the process. I have been explained architecture of the perceptron, and I have explained how to write a program, and also I have given one illustration. This is what illustration. Like this, we need to justify for every concept when we are presenting in RRM, please. All of you remember, when we are presenting or when we are giving the presentation in the RRM means research review meetings or wherever you go in the conference or anywhere, this kind of pattern is important. First architecture, next is one example. That's very much important. The models of neurons, perceptron model, the association units perform predetermined manipulation of their inputs. The main deviation from MP model is that learning is included in the operation of the unit, adjusting of weights. Every time you can change it. How weights are adjusted? Suppose today I did a project with my random weightage. Then how to adjust it? So let us take same example, chicken curry. Today I took a more major weightage of the salt. Then if I taste it, then I'm not able to eat properly. Then what should I do? I should change that only with respect to the input data only. The desired or target output is compared with the actual binary output. How weights are adjusted? So the desired or target output is compared with the actual binary output, and the error is used to adjust the weights. So then what about you see that? Please one second. So please. So how weights are adjusted? So gradient descent algorithm. So the desired or target output is compared with the actual binary output. Okay. And the error is used to adjust the weights. Suppose, so I have in my mind the taste of the chicken curry. Suppose if I could not reach the taste, then there is a gap. That gap is called error. That I have to be fulfill it. How do I fulfill it? By adjusting the weightage of the gradient only. Which gradient I have to be adjusted? That I have to be re-evaluate. Analyze and evaluate, I should take the decision which I have to be upgrade that weightage. The perceptron law gives the step-by-step procedure for adjusting the weights. The perceptron law is giving the weights. This is what I'll be going to explain with the example, which weight I have to be adjusted with the help of the logical gates. Weight adjustment convergence is an important issue in perceptron learning. If the weight adjustment converges, then the corresponding problem is said to be represented by the perceptron network. So which weight I have to be readjusted, that's very much important. So weights can be whatever the training algorithm determines the weights to be. If you take the simple case of perceptron, one layer neural network, the weights are the slope of the separating plane. It could be positive or a negative. So then what function I want to use for the deciding of the output? Activation function of a node. Define the output of that node given an input or a set of inputs. A standard integrated circuit can be seen as a digital network of the activation functions that can be on or off depending on input. So this activation function as per your requirement only, not to define as it is, as per my requirement only. So the bias value allows the activation function to be shifted to the left or right or better fit the data. Suppose y is equal to w1 x1 plus bias value. That bias value is shifting to the right or left or better fit the data. Suppose if I take the more minus value, then it will be left shift. If I take the more positive value, then it will moving to the rightwards. If I take the neutral value, then it is a better fit. You see that bias is also very much important to take care. So do I need to balance it or not? Okay. So this is what. So there are two values are there. playing the key role, weight and bias in our entire process, how to adjust the bias, how to adjust the weightage. For that, I'll be going to share a beautiful example. So that is what. This is the example for the readjustment of the weight and bias. So now I'm taking AND gate example. So please, all of you very familiar about the AND gate. So you know the definition. The known example I'm taking for understanding of the artificial neural network concept. So what is the definition of the AND gate? If there are two inputs are there, X1, X2. So if you know this definition, when one input is 0, then the result is always 0, otherwise 1. So this is the actual definition of the AND gate. Now you see that the AND gate, how I am re-representing in the form of perceptron algorithm. You see that, re-representing. So the same thing you see that I am re-representing in the form of perceptron method model. You see here is X1, X2. So two inputs are there. So X1, X2. Here I am adding one more. This is what? A bias value. So for this is what is the my processing element is AND operation. My processing element is AND operation. So this is what. So now initially you see that what I am doing, row 1, row 2, row 3, row 4. Total how many rows are here? 4 rows are here. 4 rows are here. So row 1 is 0, 0. What should I get output? 0. Row 1 is row 1, row 2, row 3, row 4. Please let us assume total 4 rows are there. So now what I want to do, row 1. In the row 1, what is my activation function is, as per this notation, you see that this is y is equal to x1 multiply w1 plus x2 multiply w2 plus b. This is the my additive function as per this additive function. Okay, AND gate. So this is what the function is. See that y is equal to w1 multiply x1 plus w2 multiply x2 plus b. So now let us see. Now already inputs defined 0, 0. Now I want to find the output value. So w1, w2 I am taking randomly. w1, w2 I am taking randomly. w1, w2 taking random value, and b value is also random value. -1 I am taking. B is equal to -1. So these are the random values. With the random values, I am testing, am I getting the right result or not? Let us say we get x1. x1 value is 0. Multiply. What is the random value I have taken? 1. 0 multiply 1 plus 0 multiply 1 minus bias value randomly I have taken -1. So finally, I am getting -1. Now with the perceptron rule, what is my perceptron rule activation function? Wx plus b. That means Wx plus b means this whole function less than or equal to 0, then y is equal to 0. So then what is the value of this whole function? -1. I am substituting here is -1 less than or equal to 0. Then the condition is true. When the condition is true, then y is equal to 0. Therefore, this row is correct and no need for back propagation. So with the random input values, I am getting the value. When I am comparing this value with my target value, both are similar. When both are similar, then this is the result is right. When the result is right, which I have taken the weightages of the W1 and W2 bias values, rightly I have taken. So I don't want to go for the readjustment of the W or bias value. Why I am not going for the readjustment? What I expected result? My target is 0. My expected result is 0. Both are same. So then why should I go? So this is the process of this. And no need for the back propagation. The similar process you need to apply for row 2 also. Row 2, what are the input values? 0, 1. So if I substitute the 0, 1, you see that if I substitute the 0, 1, this is the function. Please. 0, 1, 0 multiply. So W1 is already I have decided 1, B is -1. So 1 multiply 0, 0 plus 1 multiply 1, 1 plus -1. So that means 1 minus 1. 1 minus 1 is 0. So then I should test with the activation function. Activation function is what you see that 0 less than or equal to 0, then y is equal to 0. My expected value is 0. My target value is 0. Both are same. So this row is correct as the output is 0 for the AND gate. With the perceptron rule, the rows row 1, row 2. Similarly, you apply for the row 3 also. Similarly, you apply row 3 also. So row 1, row 2, row 3 are correct. Similarly, you apply for the row 4 also. Row 4, what about you see that? X1 is 1, X2 is 1. Random weightages, B values is that these are the values. So W1 is 1. 1 multiply for row 4. 1 multiply 1, 1 plus 1 multiply 1. So 2. 2, B value is minus 1. 2 minus 1. So 1. So finally I am getting 1. So 1 is less than or equal to with the activation function. 1 is less than or equal to 0. If the condition is false, then y is equal to 1. So my output is y is equal to 1. And this is what you see that target value is 1. Both are same. So what I have decided initially, the random values of the weightages of W1 and W2 and bias value, rightly I have selected for this example. Here no need of the back propagation. So which I have been selected the weightages, that's right. In another example, we'll find it. Then I'll end the session with another example, please. So OR gate. So OR gate option. You know that OR gate definition? You know the OR gate definition? So OR gate is that row 1. So same formula I'm applying. W1 x1 plus W2 x2 plus B. So how I'm defining this formula? OR gate is having the 2 input values and 1 bias. So that with respect to the definition of the OR gate, I have defined this is the function. Please all of you remember. W1 multiply x1 plus W2 multiply x2. Here you see that x1, x2, and this is our option. This is bias value. So then the function is what? X1 multiply W1 plus x2 multiply W2 plus B. This is the function. So now initially I'm defining the W1, W2 randomly. Random values I'm selecting. So random values 1 and bias value is minus 1. So randomly I have selected these are the values. Now I apply this formula. What is this input values? You know the OR option, OR definition. OR is if either one input is 1, if either one input is 1, then the result is always 1, otherwise 0. So this is what. So let us see here, first row I am taking 0, 0. 0, 0 input I am taking. But randomly, what are the values are decided? Initially, W1, W2, 1 and bias is minus 1. With these values, and what are the values are here? These values. What is the output? Let us see 0. X1 is 0. W1 is 1. So 0 multiply 1 is 0. Plus W2 1 and X2 is 0. 0 minus 1. So finally minus 1. What is my activation function? You see this whole result producing minus 1. So minus 1 less than or equal to 0. Then y is equal to, what is the formula? When it is a true, y is equal to 0. Therefore, this row is correct. Therefore, with my perceptron rule, whatever the randomly I have selected the weightages and bias value, it is giving the correct result only. So no need of any readjustment of the weightages. In the row 2, let us see. Row 2. Row 2 is what? You see that? Row 2 is 0, 1. X1 is 0, X2 is 1. And initially I have defined already weightages. W1, W2, 1, B is minus 1. You see X1 equal to 0, X2 equal to 0. We get, what is the function? You say that this is the formula I have to apply. What is the X1? 0. 0 multiply 1, 0. Plus W2 is 1. Multiply X2 is 1. So 0 plus 1. Bias value minus 1. 1 minus 1. So 0. So finally I am getting a 0. So then from the perceptron rule, that means activation function. If Wx plus B less than or equal to 0. So this 0 is less than or equal to 0. 0 is less than or equal to 0. Then y is equal to 0. So then y is equal to 0. When it is y is equal to 0, then actually y is equal to 0 with this weightages of the W1, W2 and bias value. But actual output is what you see that here row 2. Actual output is 1. But with this weightages and bias for this input value, what is the output? 0. So here I am getting 0. My expectation is my expected target is 1. Both are not matching. Both are not matching. So therefore, this row is incorrect as per my random weightages and bias value. So what I want to do now? So we want to values. Here, please, all of you focus much in this. This is the very important statement. So we want values that will make inputs x1 equal to 0, x2 equal to 1, give y a value of 1. Actually, what I'm expecting? Output 1. But what I received? 0. If we change W2 to 2, so now I'm readjusting the weightage of the either W1 or W2. Let us see here, if we change W2 to 2, we have, so now I'm changing the W2 random value from the 1 to 2. Initially, I have taken 1, but now I changed 2, readjustment of the weightage. Which weightage? W2. So in these two weightages, W1 and W2, 2 are here. Why I'm selecting only W2 than W1? What is the reason? My input is either 0, 1. If I change the W1, multiply 0, equal to 0 only. So no importance for the W1. So that X2 is 1. So W2 multiply 1. W2 value multiply 1 means equal to W2 only. So it is playing the influence. It is playing the major role. So that now I'm readjusting W2 than W1. So this is what we want to keep in our mind. In W1 and W2, which I'm readjusting, let us see here, W2 only than W1. Why I'm not updating the W1 means X1 is 0. So when it is X1 0, 0 multiply anything is equal to 0. So no meaning for updation of the W1. So now I'm concentrating on W2. Now W2 randomly I'm assigning 2. Now I'm taking 2. Now when I take it 2, W2 2. So W1 is already 1. 1 multiply 0, 1. Plus 2 multiply 1, 2. Minus 1. So 1. So finally it is producing the 1. So 1 activation function. 1 is less than or equal to 0. If condition is false, it will produce y is equal to 1. So then what is my target value? 1. So which is what is this producing? 1. So both are same. So my adjustment is absolutely right. My adjustment is absolutely right. So this is correct for both row 1 and row 2. Whatever the adjustment I did in the row 2, the same values I have to apply even for the row 1 also. I have to recheck row 1 whether my adjusted value is feasible or not for the row 1. If I should not check, then that process is wrong. So what I have been adjusted, now W2 is 2, W1 is 1. Okay, again I have to check it for row 1. Row 1 is 0, 0. So then what about you see that W1 is 1 multiply 0 plus W2 is 2. 2 multiply 0 minus 1. So minus 1 only. So minus 1 less than or equal to 0. So then definitely absolutely it is giving the same result only. So it will not affect even for the row 1. So this is what process. Similarly, I'll end with this slide only because of I want to share with you how to readjust the weightages. In the tomorrow session, why should I go for the adjustment of the bias and other values. Row 3. Row 3 values are x1 is equal to 1, x2 is equal to 0. x1 is equal to 1, x2 is equal to 0. We get with the function, you see that now what are the weightages? I have been readjusted recently. Recent value I have to take. W2 is equal to 2, W1 is equal to 1. So then what I want to do here is, so what is the function? W1 is 1 multiply x1 is 1. So 1 plus W2 is 2 multiply 0. So plus B means minus 1. B is minus 1. So 1 minus 1, 0. So this is the value, you see that 0. So 0 is less than or equal to 0. Then y is equal to 0. But here I received the value with this function 0. But my target is 1. My target is 1. So now let us see here. Both are not matching. When both are not matching, then I have to apply the back propagation. I have to apply the back propagation. Why should I go for the back propagation? I'm not reaching my target. When I'm not reaching my target, there is an error. What is the error? This is the gap is there, 0 to 1, there is a gap. So I should get this value. For the getting of that value, what should I do? I have to readjust the either W1 or W2 or B value. Now which I have to be readjust, let us see here. Therefore, this row is incorrect. Now, since it is similar to that of row 2. It is a process is similar to row 2 only. We can adjust, we can just change the W1 to 2. Now I am changing the W1, not W2. Why I am not changing W2? You see here x2 is a 0. 0 multiplied W2 is equal to 0. So that I am focusing on the W1. So now W1 I have changed. W2 is equal to readjusted. 2. We have finally once I substitute the W1 value, finally we get this value by applying this formula. Okay. So this is what 2 plus 0 minus 1 equal to 1. So then 1 is 1. 1 is less than or equal to 0. The condition is true. Then it will produce the y is equal to 1. So then the result is what I decided the target, both are same. So now adjusted value. Similarly, how to cross check is correct for both the row 1, row 2, row 3. Now what are the weightages of the W1, W2? W1 is 2, W2 is 3, and bias is -1. But initially I started with W1 1, W2 2, but after row 3, then the weightages of the each value has been changed. So this is what readjustment process. So similarly, you see that you apply for row 4. Row 4 is what? You see that row 4, 1, 1. Input is 1 and 1. And weightages are presently 2, 2. So when I apply this function, 1 multiplied 2, 2 plus 1 multiplied 2, 2. 2 plus 2, 4. 4 plus 4 minus bias value not changed earlier. What I decided, same value, -1. So 3 only. So finally 3. When I apply the perceptron rule, this is the perceptron rule. You see, 3 less than or equal to 0. Condition is false. When condition is false, it is producing 1. So then what I expect, my expected value is 1 and target value is 1. So both are same. So here no need of the changes in the weightages or bias. So this is the process we want to apply. So I think now you understood when should I readjust the weightage. Okay. So when I should not, okay, readjust the weightage of the value. So with the OR gate, we understood the process of the readjustment of the weightages. So if you have any queries, please, I'm ready to answer for your queries regarding the today's session. So Janardhan sir.
Sir. Dear participants.
Yeah, please, any more queries regarding this topic?
Yes, sir. As now, no questions in the chat box. My dear participants, please you can interact directly if you have any questions. Make it fast because it's completely involved research topic. Whoever are involving in this direction surely will be very much beneficial. Dear participants.
Any queries, please? Or through chat box?
Yeah, you can post your queries either in the chat box or straight away interact with the resource person by unmuting yourself.
In tomorrow's session, I'll be going to share the when should I readjust the bias value and also multi-layer concept, please. Yes. Multi-layer concept.
Yes, sir. Question is not there, sir, but one of our professor he said that explanation is very clear.
Okay.
Explanation is
any more queries, please, relevant to today's topic?
Everyone. Participants, if you don't have questions, we'll proceed for. Hello. Okay, all good. Okay, sir. It seems no questions from the participant side, sir, because actually the faculty, whoever are at least involving in this direction, then only there will be a chance to get some sort of questions because some research is involved in this.
Okay.
And the members are giving that it is very clear like that. But my
Okay.
dear participants, still he can even post, if not today, even even afterwards also till the end of this program, will I will request even our resource person to answer even at the end also. Okay.
So please, if you have any queries, you can post to this mail or maybe WhatsApp number, which I am sharing with you. You see that in the bottom side. Okay. So in the PPT, you can find my phone number, my mail ID. You can share your queries, please, regarding today's session. At least tomorrow morning, I can clarify your doubts, please. I should be very happy to receive maximum number of queries. That is enhancement of my subject also. So please, all of you, my sincere request, post a query to your coordinator or this mail ID or this WhatsApp number. So thank you, one and all.
Thank you, sir. Thank you very much. Really, it's a really very great lecture as you have covered complete insights of the artificial intelligence, which includes in particular about artificial neural networks. You have covered the topics with real-time examples, which people are very familiar with those terms. Then you have even covered the problems which are very much important for every faculty to work in the research direction. Now I request Madam Radhika to propose a vote of thanks for this session. Thank you, sir. Thank you very much from my side. Now
Thank you very much, Janardhan sir. Thank you very much.
Thank you, sir. Radhika, madam.
Yes, good afternoon, one and all. It's my great privilege to propose vote of thanks on third day, second session for 1 week online ISTE-STTP on machine learning application research challenges 2020. I would like to extend special thanks to Professor Viswanadha Raju garu for sharing enlightening knowledge on artificial neural networks with real-time examples. Sir has explained machine learning importance with real-time examples which we are going through in our day-to-day life. We are really enlightened with your knowledge which you have shared for us, sir, and I think this helps us for continuous learning and it may be very much useful for the research scholars we are looking about. Thanks a lot, sir. I would like to give it back to our Dean, sir.
Thank you, madam. Thank you very much. Thank you, sir, once again. Thank you very much for our great session today, for sparing our valuable time. Thank you very much.
Thank you very much.
Again, we'll have a session tomorrow.
Okay, thank you, thank you.
Yes, sir. Thank you, sir. Yeah, yes, sir. Yes, sir. My dear participants, next session will be at 1:30. Okay, still we have 20 minutes time because as every one of you are there at your respective place only, please complete our lunch within 20 minutes and be back by 1:30 sharp. Thank you very much. It is again today afternoon topic. Once again, it's a very much interesting topic, which is on machine learning hands-on, supervised linear regression algorithm and unsupervised K-mean algorithm. Okay, hands-on using Python. Okay.
I'm leaving, Janardhan sir. Please,
yes, sir. Yes, sir. Please, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you very much once again.
Thank you.
Dear participants, be back by 1:30.